Okay, so well, we're going to talk a little bit about automation and some of the stuff we're doing in the Hole Wizard.
Correct.
So let's go ahead and get into it. I'll be talking a little bit about the Hole Wizard.
I'll be talking about the edge deburring and some of the new options we have there.
Yeah, and I'll be bringing out some more ideas about what we're doing with pocket recognition and so forth.
And we'll both be talking about templates and drag and drop.
Yes, absolutely. So one of the things that we're striving for is to achieve functional automation. Automation is only as good as what you have control over, all right? So the other systems in the industry that put everything in a, Access database or something like that, and you don't really have any way of controlling it, make it more difficult to work with. With what we're doing, we're going to be creating functional automation. We're starting with the native Hole Wizard. You guys have seen some of this out for a while now. We've done some more enhancements to it. We're growing it further into the ability to actually fully and completely manage the automation structures. And it works with imported files, right?
Of course. Got to work with the imported files now.
Got to have the imported files. Now, we're also doing some advanced feature recognition. Sidney, why don't you tell us a little bit about it?
Sure. Well, with the advanced feature recognition, what we've actually done now is that the holes are actually recognized as you're creating your CAM part setup in the very beginning.
Right.
But not only that, we see that actually underneath now our CAM tree as well, underneath the target, because it is part of the target.
It is. It's actually a target definition now. And it recognizes a lot of information about that hole, doesn't it?
Exactly. What we're actually recognizing now, which has been requested for quite a while, is we recognize also any tolerances that are inside those holes that are created in the native CAD part.
Yeah, this is kind of MBD, isn't it?
It's exactly going there.
Yeah, exactly. It's right where we're headed. So the idea here is to capture as much information as we can from the CAD model and take it into the system, right?
That's correctly is. And we're, as you just, you're showing right now, is we even have the dump file, which anyone could look at. But we can even go another step further.
Right. Well, this dump file helps you when you're building your process. You can see the information in here that you're trapping in your logic.
Right.
Okay. So
now, yeah,
where is this info?
Yeah, let me actually talk a little bit about the feature dimension tolerances. Well, taking SolidWorks here, for example, inside the feature, when you're creating a feature inside SolidWorks, I should say, you can actually add tolerances inside the hole. Well, we capture that information.
Yes, we do. And we make it available to you. So let's take a look at what we're getting in here.
Well, what you see, first of all, in the hole, when we actually look at the hole, you can see that we're actually getting the dimensions, but not only the regular dimensions, we're also getting the modified dimension. We're getting the minimum and maximum and the delta.
The delta, which is very powerful. We're going to talk about that in a minute.
Exactly.
If it's a symmetric tolerance, then of course it doesn't impact the machining. But if it's an asymmetric tolerance, then we're capturing that modification and that delta offset so that we can use that in our logic.
Right.
Okay.
Now, it's not enough that we actually capture that information, but now to every single one of those parameters that we captured, we actually add a whole wizard parameter so we can actually attach it to our process as well and use that information.
Right, and so you see here an entire subset within the counterbore diameter. There's a subset of those tolerances that can now be trapped and put into that machining process.
Correct. Well, actually, let's take a look of exactly how this works. If you take a look right over here, I'm just going to take the counterbore hole that we have, for example, and if we look inside, this is a 17 millimeter through hole with a counterbore of 32 millimeters, but both of those dimensions have an isometric, they have a 0.2 plus and a -0.
Right.
Now, if we take a look at the actual through hole itself, it is still a 17 millimeter hole. So it's an actual dimension, but all we have is the tolerances. Yeah. So now we're going to create a CAM project, and we're going to create a home position. I like to always add also the X or Y position, in particular case the Y position. And I have it set up that it's actually automatically recognizing the target and the feature. Now, as it's recognizing the target, it's already recognizing the holes as well.
Now, that's available for switch too, right?
That's for everything.
We don't have to do that.
That's
but
correct.
We have an option in settings to allow you to do that during that time.
Now, let's take a look at the cam tree underneath the target, and let's take a look at that counter-bore hole. You'll see that if we open up the information to show holes, you can see that every single parameter that we were looking for, those tolerances, whether it be the minimum tolerance, the maximum tolerance, the modified tolerance, or the delta tolerance, everything is available for you to use. And let's take a look at how we actually put this to use. Whoops, we actually went ahead a little too far.
Sorry.
Let's go back. Okay.
So you were there.
Yeah, is there a way to speed this up? I guess not. But, so as we're going through the steps again, it's a 17 millimeter hole and a 32 millimeter counterbore. I feel like, replay.
We needed a reiteration on that, right?
Right, exactly.
Repetition
exactly.
builds
And don't forget
the
about
memory.
the tolerances that I
Yeah.
talked about before. This is a test, so you're going to be asked about this question. That's why we're going over it, just to make sure you know it.
Yeah.
Anyway.
Sure.
And of course, the actual dimensions. And we're going to go and create our coordinate system as you're about to see.
Yeah,
just
now,
like
while
we did
this is
before.
going through that, remember, we're not modifying the model. So this is no detriment to the actual definition of the model. We get to use these to capture what we need to capture.
Exactly, exactly. Okay, and as you see, again, we are now going to be recognizing the holes. And this is, by the way, we don't have to do this automatically. If you want, we can click the recognition instead and do
Right.
it manually. Now, let's actually go and take a look, as I said, at the information that we captured. And as I mentioned before, all of that information is there in front of us. We don't have to start adding it. By the way, if you don't have tolerances on it, it's the imported part, you can add these tolerances manually as well. You can open it up, add the tolerances as you wish.
Right, in the imported files, we can get that data from PMI data, but that's coming. We haven't gotten there yet.
Now, let's take a look now, and we'll see exactly how this is actually, how we actually use it inside the operation. So I'm going to use a drag to the hole option, and I'm going to drag it to that particular set of holes. Now, it's creating the operations at this point, and if you take a look, in a moment, the operations will be shown in the cam tree itself. And let's take a look first at the through hole that we've done with the drill. Remember, it's a 17 millimeter physical hole. However, the tool itself, 17.1. That means I used the modified information about it. But now, and you can see also again that the actual hole is 17 millimeters. Now, as far as the counterbore goes, that's a profile operation. So there I've actually gone into the technology and used the delta information to capture that, to modify my offset. Always using the same geometry and keeping it associative to that geometry.
Right. And so a lot of this stuff, remember, we're going to be putting more and more functionality into the feature recognition.
Okay.
Okay, so as we begin to talk about this, we have the feature tolerances. We're also starting to play with tool tolerances, okay? Right now, they're in the settings area, and you can actually go in and set up the tolerances. It's not the optimum place for them, but we needed to start somewhere. We're going to start putting these into the toolkit only in the machining process, so that it's not going to impact the toolkit in the rest of the system, but we'll have the ability to create tolerance bands within the toolkit in the process, so that when it goes to select a tool, it'll be able to select a tool that falls within that range of tolerance, giving us a more functional use of being able to use a tool that's already in the kit instead of creating a new one. So this is going to be pretty big when it gets functional. And this is we've been working on to try to build that foundation for digital manufacturing, making automation work for us instead of us working for it. Come on. Now, this is near and dear to your heart, right?
This is something I've been working on, well, basically for quite a while. But let's first talk about, we've had edge deburring for a little while already, and I've done some improvement. Before we've done, but I should say that the development team has done a lot of improvements on it.
Exactly.
I always have to give credit to the development team. Now, one of the things we've always had is we've always had, at least for a while now, 3D model gouge protection. This is extremely important. Just make sure that the shank of the tool does not crash into your model. It does not actually gouge the model, I'd like to say.
Right, exactly.
Now, one of the options that we've also had for quite a while is the option to ignore floor angles less than a specified angle. Because many times you have a model that has both sharp edges and already chamfered edges designed into the model itself. So this allows you to have control of exactly where you want to cut. In this particular case, all we want to cut is just the sharp angle.
Just the sharp angle. But we also have some other control here as well.
Yes, we've just added, okay, this is now available in 2023 SP1. We have the option to actually give it a specified angle. You have the chamfered edges already you have modeled onto the part itself. I want to do just those edges. No problem. Now we have a filter that you can do just a specified angle. Gives you complete control of what you want to do.
So in two operations, we could do both the sharp edges and we could also do the 45s. Be very easy to handle. Now, this is something that's really cool. And we worked on this, what, 2 months ago?
Oh,
3
a
months
little
ago?
longer than that, but yeah.
Kind of dialed it in.
Yeah, something like that.
So,
And this is called dynamic cutting diameter. When you have a chamfer mill, you have a minimum diameter and a maximum diameter. When you're normally cutting the way we did before, you always cut on one edge and you're basically wearing down that particular edge that you were always cutting at. What the dynamic control between two diameters actually does, it allows you to actually go between one diameter, the smaller diameter, and the larger diameter and back. This way, you're always moving your diameter on the tool along the edge, which, by the way, what that does, it allows for less wear on the tool itself. This is very, very important for hard materials and also when you have large parts.
won't create a notch in your tool. And this does it dynamically, which is why the name is there, right? So here's where you set it.
Exactly. Inside our technology field, we've always had the option, as you see over there, we can see that we had always the dynamic cutting, the constant cutting diameter, but we've added now over there the dynamic cutting diameter. Now, you know, I'm going to get to a point where, you know, I'm not going to talk about it. Let me just show it to them.
Okay, let's take it in there and show it.
All right, now, if we go into the edge deburring recognition operation, you'll note that in the technology field, we had the constant cutting diameter, which we always have, but we've added, as I mentioned before, the dynamic cutting diameter, allowing you to go from a minimum diameter to a maximum diameter. The minimum diameter always being the minimum that is available on that particular tool, and the maximum up to the maximum. Now, let's create a geometry. In this particular case, I just want to create my geometry using the top face. So I'll choose the option of just one face, and I'll click on that face. Now, note also that little boss.
What about that boss, man? That boss is going to cause us a problem, isn't it?
That's right. It may create kind of most cases, but let's see what actually happens. I'm going to use a 10mm chamfer and mill. And what I'm also going to do is I'm going to give it a chamfer depth of 0.5 millimeters so we can actually see what's going on. Now, let's go into our technology field. As you see, the dynamic cutting diameter is set right now at 1 to 4, but the maximum could be up to 10 millimeters. And the minimum as small as that particular tool is.
But you want to stay up off of that tip a little bit, right?
Right, exactly. So let's go into our minimum diameter. And, you know, I'm going to set it at 2 millimeters for the diameter on the minimum
So you don't want to go that high on the big diameter either, right?
Now, my maximum is 10, but I don't want to go that high, so I'm going to set it at 8 millimeters.
Very
Just
good.
going to save and calculate, and let's take a look at the simulation, okay? Now, as I'm doing the simulation on the part, pay attention for a moment to the Z level. I'm going to start the simulation, and I'm going to stop for a moment. Note it's at 1.5 millimeters depth. Now, as it's going around, as you'll see, the depth will get further down, and then when it gets to its maximum, it comes up. Now, note, you'll see what happened over that boss.
Protected it, didn't it?
It protected it, and we'll see that in a few moments exactly what I'm talking about. As you see, as it's going down the side view, you can see that how it goes deeper and deeper and moves itself away from the part, always keeping it. Now, look at the boss.
That's pretty
We're getting
cool.
towards the boss, and all of a sudden you see the boss is there. It goes up to its minimum diameter, jumps over that particular boss, keeping a chamfer, though, on that edge. And then continuing over to the other side. This is something that has been, I think it's a major improvement inside our edge deburring operation over here in 2.5D. You can see over here inside our simulation of Solid Verify. You can see as it's going further and further down along the part, as it gets towards the actual boss itself, you'll see that it jumps up and continues on the entire part.
Gives us a nice consistent chamfer all the way through there, even though it was doing the avoidance. It's very cool.
Thank you.
Good job, Sidney. So, now we've had the feature recognition stuff in iMachining for a little while now, and we pick up the faces, you know, using the smart face for the pocket bottom, pick up the chains, we pick up the outside diameters and such, but we've also done something a little bit newer than that, haven't we?
Yes, we've taken that information and all that feature recognition, and we've added that now to our regular pocket operation. So our pocket operation now also has automatic feature recognition, including faces and the chains and the outside, which I always like.
Now, what that does for us is allows us, even in pockets, to take advantage of that feature recognition for the multiple depth pockets. To say, in this case here, you're going to see each of these pockets are at a different depth, and yet with a single selection in there, we're actually able to manage all of that simultaneously. Okay. Now, SmartFace is where this comes from, right? Sidney brought us SmartFace several years ago.
Now, several years,
And
exactly it.
This is pretty cool technology. Did you recognize at the beginning of this where this was going to be able to go?
This was just the first very step, and I knew that once we got this, we can go far away. SmartFace actually is the base of everything that we have inside 2.5D operation, whether it be iMachining uses the recognition for the levels and everything, and the rest of the stock, according to the SmartFace, where it automatically recognizes the open edges, it automatically recognizes the bosses, and it also recognizes where holes are, so not to create a geometry in those particular areas.
Exactly.
Now, like I said, drag and drop would not be possible without having the option of SmartFace. SmartFace. Exactly.
And so that allows us to do things like we're going to show here, where we can actually drag and drop that process. Now, hey,
Wait,
how'd you
just
do
a
that?
second. Yeah.
How'd you do
Well,
that?
what I did over here, by the way, is in order to grab all of those pockets, I just held my control button on my keyboard. And then when I let go, that's when the operation is being created. And by the way, we've also added now in 2023 SP1, when we do this, if you want, there's an option that even though I created this in one move, I can get one operation for each one of those faces. Okay.
Pretty cool, right?
That's correct.
Now, what else can we do with this?
Oh, templates.
Yeah. We've actually done a webinar here just in the recent history that we go through all of the management of templates, right? So if you want to see that, you can look it up on our website, but based on what we're doing there, we're able to take the drag and drop functionality and capture different template alignments based on what we want to do. So again, making the automation extremely functional and very useful for us, even including this right here, where we're grabbing something off of the tree and we're able to go ahead and replicate the use of that. And Sidney, what happens when we do that?
Well, what you're doing over there is you're actually taking in your operation, okay? And what you're seeing over here is you're getting different levels. Even though you took the operation, there was on one particular level, when I touched the face using that operation as a template itself, it created another operation according to the depth of that particular pocket.
Right. So even though we used it in two different manners, we can drag and drop with the control key, or we can drag from one into a pocket and then come back later in the operation set and maybe just take that one off the tree and reuse it. Very powerful. Mm-hmm. Now, these templates, like we talked about, they're located in certain directories, and we can manage all of that in the part settings. And this
By the way,
gives us
Ken
the ability.
had done a webinar about 2 months ago explaining exactly what how to set this up. So if you want to get a further in-depth view of that, just take a look on our website for that webinar.
And they can call you for that, right?
Wait, there's a question.
Okay.
Okay.
Functional automation, not just crazy automation. We don't know what's happening, and you have to figure out, right?
You got it.
And you
That's
word,
it.
functional automation.
Okay, so there's a question here for Sidney. Can dynamic chamfer operation cut from larger diameter to smaller?
At this moment, it starts from the small one to the larger, and then it goes back up.
Yeah.
Okay? It doesn't go just from small to, maybe I didn't say this correctly, but it doesn't just go from the smaller to the larger. It goes from the smaller to the larger and then goes back down.
Yeah.
Okay?
Now,
To the smaller.
let's get off stage.
Okay. Thank you very much.
Thank you, guys.